Hello, welcome to our unique learning system math lesson. My name is Charlotte Lucas. I am an autism low incidence mentor teacher with Richmond Public Schools, and I am delighted to be able to work with you today. Our math lesson today is ratio and proportional relationships. Don't let those long words scare you. It's really easy work. First, we will discuss some vocabulary. Then we will show and model examples of ratio and proportional relationships. We have a lot to do, so let's get to work. Let's talk about ratios part to part. This is a ratio here. This is a part-to-part ratio, okay? A ratio compares two numbers and shows how they are related. A part-to-part ratio shows how one part compares to another part. So, this is an example of one blue ball for every 3 green balls. One blue ball for every 3 green balls. The first part is the 1. 2, where you have your colon, 3, 1 to 3, part to part. One ball for every 3 balls. The blue ball is one part, the green balls are another part. The ratio is 1 blue ball to 3 green balls. 1 blue ball to 3 green balls. It is a 1 to 3 ratio, okay? A ratio describes a pattern. We draw one blue ball for every 3 green balls we draw. The ratio 1 to 3. So for 2 blue balls, we draw 6 green balls. If we draw one blue ball for every 3, if we draw one blue ball for every 3, then if we draw 2 blue balls, we would have to draw 6 green balls, 1 to 3. All right? Let's think about it another way, just to be a little bit helpful. Let's think about bicycles. How many wheels are on each bicycle? 2. So for every 1 bicycle, there are 2 wheels. For every 1 bicycle, there are 2 wheels. So if I were to add a bicycle, I would have to also add wheels. So if I added another bicycle, I would have to add 2 more wheels. Is that correct? So when we think about part to part, let's think about bicycles, because for every 1 bicycle, there has to be 2 wheels. But if I have 2 bicycles, I'm going to need 4 wheels. The ratio is still 1 to 2, okay? That's one way for us to think about it. So let's see if we can create the model for you. Randy is putting away supplies from Midway Field Day. He puts away 1 pool noodle for every 5 rubber ducks. We're going to use objects to show the part-to-part ratio of the number of pool noodles to the number of ducks he puts away. That's a comparison. Every time he puts away 1 noodle, he actually puts away 5 rubber ducks. And then we'll write the ratio. So for every 1 noodle, we're going to put 5 ducks. 1, 2, 3, 4, 5. For every 1 noodle, he puts away 5 rubber ducks. Let's read it again. Randy is putting away supplies from Midway Field Day. He puts away 1 noodle for every 5 ducks. That's the comparison. For every one noodle he puts away 5 ducks. Let's see if we can represent that. We can also show with just using a dot for each one. One dot represents the noodle to every 5, 1 to 5. And the ratio would be written 1 to 5. And we're talking about part-to-part ratios. So for every one noodle he put away 5 ducks. And that's the comparison. The ratio is written 1 to 5. This in the middle, those 2 dots on top of each other, that is a colon, and the colon must be a part of how it's written. 1 to 5. 1 pool noodle to 5 rubber ducks. All right, let's go on. It says Randy is counting supplies. Let's make this a little bit bigger. You know, Miss Lucas has trouble seeing all these little words. You guys, I'm sure you have no problem with this, but I have a little bit of problem. So let's make it a little bit bigger. Randy is counting supplies during midway field day. He counts 3 water squirters for every 8 hula hoops used. Use objects to show the part-to-part ratio of the number of water squirters to the number of hula hoops he counts. And then we're going to write the part-to-part ratio. So for every 3 water squirters, 1, 2, 3, the first part, there are going to be 8 hula hoops. The second part, 1, 2, 3, 4, 5, 6, 7, 8. Okay? For every 3 water squirters, there are 8 hula hoops. 3, 8. That's the comparison. Randy is counting supplies used during midway field trips. He counts 3 water squirters for every 8 hula hoops used. 3 to 8. The colon in the middle is when you see that colon, you're going to say 2. 3 to 8. All right, let's move on. And here we see again 3 water squirters to 8 hula hoops. And again, we can write that 3 to 8. The comparison would be, if we use the objects again, the comparison would be 3 water squirters, 1, 2, 3 to 8 hula hoops. 1, 2, 3, 4, 5, 6, 7, 8. And I want to make sure that I fill all of these out, because when you get home and you're by yourself and you're doing these, I want you to have a good example to follow. So if we fill out all of the boxes, it makes us to know that we have done that. First of all, that we've done our problem correctly. We filled out our illustrations correctly. Let's go to the next one. Now we're going to be talking about, at first we were talking about part to part. Now we're going to be talking about part to total. Part to total. It's a little bit different. The ratio looks the same, but the language is different. Part to total. The ratio looks the same, but literally the language gets to change. For example, I'm going to try and use a box of crayons as an example. There are 8 pieces of crayons in this box altogether, but only one of them are red. In this box, there are 8 pieces of crayons, but only one of them are red. The ratio is 1 to 8. One of the 8 is red. The ratio of red crayons in this box is 1 to 8. The whole box, you have to think about the whole container first. It's 1 to 8. So that helps to clear up things. So let's read and get a good description. A ratio compares two numbers and shows how they are related. A part to total ratio shows how one of the total compares to the total. For instance, 1 blue ball for every 3 total balls, for every 3 total. So 1 of the 3 is blue. The blue ball is 1 part of the total ball. So 1 is blue. The total is 3. 1 to 3. When you see this colon, you say 2. 1 to 3. The ratio is 1 blue ball to 3 total balls. It is a 1 to 3 ratio, and this is how you write a ratio, 1 to 3, just like that. Okay, so now let's see. A ratio describes a pattern. We draw 1 blue ball for every 3 total balls we draw. So if we draw 3 balls, we have to color one of them blue. So for 2 blue balls, we draw 6 balls total. For every 3 balls, there should be 1 blue. So if there are 2 blue balls, there will be 6 balls total. Let's see if we can do a quick demonstration of that. We'll read our word problem first, and then we'll fill it in. Then we'll check to see if we've done it correctly. Randy is unpacking sports equipment to use for Midway Field Day. He unpacks 5 balls for every 9 pieces of sports equipment. We're going to use objects to show the part to total ratio of the number of balls to the total number of pieces of sports equipment. And then we're going to write the ratio. So the first part is that he unpacks 5 balls for 5 balls, okay, for every 9 pieces. So 1, 2, 3, 4, 5. The total number was 9. So that's 5, 6, 7, 8, 9. The total amount of sports equipment was 9, but of the 9 pieces, 5 of the balls, 5 of them were balls. Of the 9 pieces, 5 of them were balls. So the ratio is 5 to 9. This in the middle is called a colon. You have to use that. So it would be 5 to 9. This is in a part to total. And we're thinking about the box of crayons. The total number of crayons in the box were 8. Only one of them were red. In this the total number are 9 and 5 are balls. Okay? Let's see if we did it correctly. We did. 5 and the total is 9. We can do that again. We can have 5 balls. 1, 2, 3, 4, 5 out of the total number, and the total number was 9. 6, 7, 8, 9. 5 of the balls were 5 of the total amount of equipment were balls, and the total amount of equipment was 9. 5 of the 9 were balls. 5 to 9. All right. I think we can do one more. We can do one more because what we're trying to do is see the difference between a part-to-part ratio and a part-to-total ratio. Right now, we're doing a part-to-total. Okay, let's read the word problem. Of course, I've got to make it a little bit bigger so I can see it. Mrs. B is giving out supplies to volunteers at Midway Field Day. She gives out 7 clipboards to every 10 field day supplies. We're going to use objects to show the part to total ratio of the number of clipboards to the total number of field day supplies she gives out to volunteers. And then we're going to write the total. So she gives out 7 clipboards to the 10 field day supplies. So we have to show the 7 clipboards. 1, 2, 3, 4, 5, 6, 7. 7 clipboards to how many field day supplies does she have altogether? There were 10. So if I have 7 here, how many more pieces am I going to put over here? 3 more. 8, 9, 10. So if we know that we're doing a part to total, we count the whole total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The whole total is 10. Of the 10, 7 are clipboards. So if we read the word problem again, is Mrs. B is giving out supplies to volunteers at Midway Field Day. She gives out 7 clipboards for every 10 field day supplies. 7 to 10. 7 to 10. This is our colon. 7 to 10. Okay, and we're able to see if to check ourselves to see if we did it right. There it is. 7 to 10. The total is 10. The total is 10, and 7 of them are clipboards. And remember, when you're thinking about part to total, think about the box of crayons. The total number of crayons in this box is 8. And of the 8, 1 of them is red. The ratio would be written 1 to 8. So here we have our demonstration here. It says 7 clipboards. 1, 2, 3, 4, 5, 6, 7, and our total was 10. 8, 9, 10. All right. I think we did a great job with this today. We learned 2 types of ways to represent ratios. The first one was part to part. Part to part shows the comparison of how many are from the total. So 1 of 3. If you're thinking about a bike, when we're thinking about part to part, we were thinking about the bikes. Every bike has 2 wheels. The ratio is 1 to 2. That's part to part. So if we're just thinking about bikes, we're thinking part to part. 2 wheels for 1 bike. If we're thinking about part to total, we think about a box of crayons. There are 8 pieces of crayon in the box, and only 1 of them is red. That's 1 to 8. The total is 8, but only 1 is red. Part to part to total. Maybe we'll talk about that again. Maybe we can find some other illustrations and try and do this again. In the meantime, you did a fabulous job. I'm very proud of the work that we did today. I hope I get to see you again next week when we'll also get an opportunity to talk about ratios. Thank you. See you next time. Be good now.